Everyone, today we are going to continue our lesson for the Environmental Science 2 lesson number 3. Today we are talking about natural lighting and architecture. So I am Muhammad Faris Hilmi will present to you this topic today. Harness the light. Architect must design building that responds well to the natural light source, which is the sun. Besides the sun, as an architect, we also design spaces or buildings that using artificial light too. Many important activities that involve human need light to get it done. Okay, for example, studying or play some games with. There are so many games. Almost all games need light. Okay, so without light, there are lots of things can't be done. However, the sun gives us heat together with light. So as an architect, we have to design on how to harness the light properly without taking too much heat and make the occupants uncomfortable. Orientation. Building orientation is the first thing to do as you start your design. You must identify three things. Number one, basic sun movement, or in a short way, just find the north point. Number two, hottest hour of the day. For example, in Malaysia, the hottest hour of the day is between 11 to 11 a.m. to 12 p.m. And number three, the sun glare period. So this is quite important because we already learned in the previous class where sun glare is very uh, annoying to human activities. It's blinding us for doing important things that we need proper shades, especially during this period. Okay, so in this diagram, it shows two things. There is uh, two things. All right. Okay. Number one is northern hemisphere area, where the sun is actually most of the time is on the south. Okay, so most of the time the sun is on the south of the building. So when you want to design your building, you can see here the building is designing here. They put the solar panel or photovoltaic on the southern side of the roof. And then you can see also a very minimum window opening on the south. Alright. However, you can create huge opening to the north side of the building. It's because of there is no almost zero sun directly from the north when you are on the northern hemisphere on the earth. Okay, so when you have this, it is mean that you are only having a big daylight on the north side. Okay, you also have to know the sun glare period where you need to shade your building properly when the sun is actually very low and give you glare. So positioning your shading device is quite important during on the south. The positioning is important. Where you want to put it, you must study the sun path for each place you are designing. Okay, what about the next one? The next one is showing the southern hemisphere of buildings that is built on the southern hemisphere. What you see here is actually very similar to the northern hemisphere. The difference is only one thing, where the sun is most of the time. On the southern hemisphere, the sun mostly on the north. Either it is June or it is December, it is still on the north side of the hemisphere. Although you are on the southern side of the hemisphere, your sun is on the north. Okay, so you must understand the sun orientation. Therefore, you position your photovoltaic on the northern side of the hemisphere, or on the side of the elevation, sorry. Then you also got to design the windows to be smaller on the north but bigger windows on the south. Okay, so when you have bigger windows on the south, means that it's because of there is pure daylight coming from the south. There is no direct glare, and you have to provide proper shading on the north side of the building. Okay, then what about those buildings on the equator? For example, Malaysia, very near to the equator. However, the location of Malaysia is slightly northern hemisphere. So that means when you are on the equator, the sun is directly from the left to the right, from the east to the west of the building, and also on the top of the building. So, and then at a certain time of the year, it will be on the south, and sometimes on the north of the sun will be on the north of your building. So the way you design it, actually your biggest opening should be on the east and west, not the biggest opening should be on the south and north for the opening and located in the equator. All right, so moving on to natural lighting, or we call it daylighting. The source is sunlight. Daylighting is lighting an indoor space with opening such as windows and skylight that allow daylight enter into the building. Daylight has becoming increasingly important to reduce the energy demand of a building and create healthier interior environment. To use natural colored daylight to illuminate interior spaces can create interesting effect caused by variations in intensity during the day, influencing the shading planes and the hue and the depth of colored surface. The most common way to admit daylight into the space is by windows. Their vertical orientation means that they selectively admit sunlight and diffuse daylight at different times of the day and year. Therefore, windows on multiple orientation must be usually combined to produce right mix of light for the building. So this is the example of different orientation, either vertical or horizontal or more organic shape or evenly sized also can. Ways to improve the amount of light available from a window. Number 1, place the window close to a light colored wall. Slant the sides of the window openings so that the inner openings is larger than the outer opening. Use a large light-colored window sill to project light into the room. Different types of grades of glasses and different window treatments can also affect the amount of light transmission through the window. Light reflectors. Once it is used extensively in office buildings, the reflectors is used when the artificial lights provided poor illumination. So, in this diagram showing that the light reflector is put above the window. This light reflector is highly reflective material so that the diffuse light will reflected into the building and then it reflected again, scattering around the room at the using the ceiling surface. The ceiling surface usually bright colored material, and also it is most of the time it is flat, so that the light, whenever it is hitting the ceiling material, it will scatter in any direction so that the illumination of the office room become a lot more brighter. Light shelf. What is the difference between light shelves and light reflector? Okay, the difference is not much, it's very little. The function is almost the same. The architectural element on the building also same. Okay, so light shelf is an architecture element that allows daylight to penetrate deep into a building. This horizontal light reflecting overhang is placed above the eye level and has a high reflectance upper surface. This surface is then used to reflect daylight onto the ceiling and deeper into a space. Light shelves are generally made of an extruded aluminum chassis system and aluminum composite panel surface. Sometimes light shelves also use mirror to do better or higher reflection. They are also designed to shade near the windows due to the overhang of the shelf and the help to reduce the window glare. Exterior shelves are generally more effective than shading device than interior shelf. A combination of exterior and interior shelves will work best in providing an even illumination gradient. Alright, so this diagram showing the difference of the sun angle at different time of the year. The summer sun will be more vertical in terms of angle compared to the winter sun, which is very low angle, so it will give very different effects to your building. Okay, the low sun angle will give a very high glare. At the same time, it is easier for you to adjust your uh, light shelf or light reflector to be interior of the building. And then during the summer, you can see that the design of the light reflectors and shading device is designed differently. It is so that it will be for the different usage, So here you can see here the number A, the label A here is actually exterior sunshade. This is actually to protect the summer sun to heat the building, especially through the window. It will actually block more shades. And notice that the angle of the sunshade is actually towards outside. It is quite important because if it is rain from similar angle, the water will drip out towards outwards from the building, from the window. Okay, and then the number B showing the light reflector or light shelf. It is installed interior is because of, if you can see the diagram showing that the winter sun will enter through the top window and then hit the light shelf, and then it will be reflected out on the surface of the ceiling. Okay, so what you see here is that the light from the winter sun hit the interior light shelf and then bounce to the ceiling, which is a slope ceiling in this case. And lastly is the E here is the green roof. Why green roof is installed on the top of this building? It is because of the sun again. The sun that I said, it gives heat together with light. So when you install green roof with real grass and soil that have water on it, the temperature will be reduced more than 50% of the heat that coming from the sun. So the architecture light shelf have been proven to reduce the amount of artificial lighting in a building, that as they can reflect light deeper into a space. As an aesthetic, light shelf integrate themselves with window designs or curtain wall, which make them aesthetically pleasant. Limitations: number one, it's not suitable to all climates. They are generally used in continental climates and not in tropical or desert climates due to the intense solar heat gain. Glare control or drapes may be required. They also require higher than average floor to ceiling heights in order for them to be effective, approximately 3 meter. Skylights. Horizontal windows or some domes placed at the roof of buildings often used for daylighting. Skylights admit more light per unit area than any windows and distribute it more evenly over a space. They are also therefore the best choice when daylight is being used to illuminate a space. During warm season, skylight with transparent glazing will cause internal heat problem, which is best treated by placing white translucent acrylic over or under the transparent light glazing. Using skylight with at least 2 panes and a heat reflecting conditioning coating will increase their energy efficiency. Daylight factor. For convenience, the daylight within an interior is quoted as a fraction of an outdoor illuminance or daylight factor. Naturally, the factor will vary at different positions within the room, but at any one point, the ratio should remain fairly consistent so that the interior natural light will change in proportion to variation in the outdoor illumination. Therefore, the factor to calculate it is of the daylight factor is like this: indoor illuminations indoor illuminance at point times 100% divided by outdoor illuminance from unobstructed sky, then you get the daylight factor. Daylight factor is the amount of daylight reaching to a point or a surface that it is split into 3 components. Number 1, the sky component, or SC in this case, is the light reaching the point directly from the sky. Number 2, the external reflected component, or ERC. This is the light that reaches to the point after being reflected from surface outside of the room, such as buildings or road. Number 3, the internally reflected components, or IRC. This is the amount of light that reaches the point after being reflected from one surface in the room. So what you can see in this diagram is the 3 components of daylight. When you see the number 1, sky component with red lines, it is showing the sky component directly from the sun through the window. Then number 2 is the external reflected components, which is showed in the green dotted lines here. It's actually to give you the example that it is the light is actually reflected from the external building and then enter the room through the window. And another one is the internally reflected components. They are coming from many angles, but for example in this diagram shows that the sun reflects the building and reflect again on the ground and then reflected one more time through the window. You can see this dotted blue line, and then lastly it reflected to the ceiling before it enters into the area of the internal room. So this internal reflector components has been reflected by the light source many times, means that the light intensity has been reduced many percentage. Okay, so this is the daylight design strategy. This drawing shows an example of northern hemisphere building. Why? It is number one because of this north facing roof monitor, which means that they have a very high window facing the north, which means it's only allow the daylight to enter through the window and then reflected on the ceiling and reflect again to the internal space of the building. And then you can see here that the building have light shelf and also exterior shading device above the window level. This is again similar to the slides before, where when you have a summer sun, it will be shaded by the exterior shading device, and then if there is winter sun, it will reflected on the light shelf, internal light shelf, and reflected again on the ceiling before it refract scattered into the internal space. Alright, since the shading device and the interior light shelf is positioned higher than human head level, in this case normally the position is at 2.1 meter, the vision glazing is at 60 per inch maximum. And then you can see here that also have the brick wall, a solid brick wall here at 30-inch minimum. This is actually to control the amount of sunlight to enter into the building and only daylight to enter at maximum capacity into the internal space. So glare. Direct sun causes glare. If you have window, then you will have a very strong glare enter your internal space of the room. So, as an architect, as a designer, how are you going to solve this issue? Shading devices. You, as an architect, must design for shading and or shading devices. Designing daylighting system, you must have to know the system. Okay? Combine window design with shading device, internal and external shading device, or control the direction of sunlight and skylight. If you are combining these two, you will get an optimum daylight system for your building. Alright, so what we have to do is by combining the shading device in by these two things. Number one, you have installation, which is most of the time it is fixed. So you have part of the facade as your shading device or mounted inside, like the light shelf slash light reflector. And another type of shading device is using system. Using system, there are two types, of system. One is fixed system and another one is operable system. Fixed system means that it is fixed in terms of shading device movement according to the time. But operable system is actually uh, is allow for the user, human, to operate the shading device whenever it is necessarily to be changed. This is one example of horizontal shading device. It is important to be designing some space in a certain area of the building to have horizontal shading device. It's because of number one is that the space that you are using here is for human activities. So this you need a clear space on the ground so that the the space is still well lit, external, naturally uh, naturally uh, ventilated, and also comfortable to be used on the outside. And then another type of window and shading device design is by vertical shading device. Okay, in this photo it shows that this the design is actually because of the limited human activity at the area. In this case, the area is balcony. So here there are two levels of balcony. So the space is limited for human activity. The space cannot be used widely, and then the shading device that is suitable is actually vertical shading device, because of it is easy to install, at the same time giving safety feature at the balcony itself. Skylight, an opening on the roof that is covered with translucent or transparent material that is designed to admit light. So there are many types of skylight design these days because they the invention of sun shading. For example, in this photo on the left, as Makati shopping center, shows that the skylight is huge. At the same time, it has a beautifully designed shading device on it. It is a fixed shading device from what I can see. So that means it allows a few percentage of light to enter the building internal space. Another one example here is Rosebridge House, where the skylight is located on the side of the building, which giving the house a very interesting light coming in into the building, which is at the high ceiling level, so it actually reduce the amount of glare enter the building at human eye level. The other way of doing designing your skylight design is by designing a light well. In this case, you can see that the light well is actually looks like an outdoor space within a building. So the reflections of building materials on the sides of the walls, which is light colored wall, for example here is white, it will give reflections to the lower part of the building, and it is making the area well lit. This is another example of light shelf that is actually positioned inside the building. You can see that the outside of the building is shading device and the inside is light shelf. So you can see the reflected light on the ceiling is actually quite strong. At the same time, when you are in the room, you won't feel very high glare. Another example of skylight design is by designing a clear story. A clear story is actually a very high ceiling, which is normally more than 2 stories or 2 stories and above. And then this actually helping the lower part of the room or space to get lit by through the clear story window. Reflections around the windows actually helping the internal space become light well better. This is just another example of skylight design. This is one example, and this is another example. So, as a student, of architecture, designing a space that responds well to the light is very important, because besides giving the light into a space or room, it also creates mood. What is mood? Mood has different emotion in a human. So light can also affect mood of people. So as an architect, you must able to design both space, its function, and also able to control or change the mood of the occupants, and most of the time changing into a better mood, not change into harsh or bad mood. That is not what architecture teaches us. Light have the power to change mood. Research shows that an adequate amount of light improves the mood and energy levels, while poor lighting contributes to the depression and other deficiencies in the body. The amount and type of lighting directly affect concentration, appetite, mood, and many other aspects of daily life. Bright light can heighten emotions. We may experience both positive and negative emotions more intensely under brighter light. In 2014 study, a researcher asked volunteers to assess the aggressiveness of a fictional person, the three attractiveness of three women, and the appeal of different spicy chicken wing sauces. They are also asked volunteers to report how they felt about a series of positive, negative, and neutral words. Overall, volunteers seated in a brightly lit room judged the character as more aggressive and the women as more attractive than those in dimly lit room. They also express a preference for spicier chicken wing sauces and felt more strongly about positive and negative words. When it comes to both negative and positive emotion, the reactions of volunteers were more intense under bright light. The example of this photo here shows that even colors of light can affect the mood of expression on our faces. Alright, so you can see on the first top and the lower top photos are all differently lit face and also have different angle of light. For example, the light that shows that given in a blue color light will give the person with different impression, which is very cool feeling. And then if you give a warm light to the facial expression, it gives you a different warmer feeling. And then if you lit the face on the side, so the other side of the face become under the shadow, it gives a mysterious feeling in the photo. So light can affect emotions. Blue light can also make us feel more energetic. How? The exposure to the blue light during the day can give us extra energy and make us more alert. A recent study found that participants who were exposed to short wavelength, high energy blue light were more productive. They were able to complete cognitive tasks more quickly and more accurately than a control group. The blue light increased their alertness not only during exposure but for a full half hour after blue light exposure ended. However, it can become a problem at the bedtime. While blue light can give us much needed energy boost during the day, it can also make it harder for us to sleep at night. Exposure to blue light from smartphones and laptops in the hours before bedtime suppress our body's production of the sleep-inducing hormone melatonin, which can make it hard for us to drift off to sleep. As you've probably noticed, if you ever struggle to fall asleep at night, sleep deprivation have a whole host of emotional and physiological side effects, from impaired judgment and heightened stress to higher blood pressure. So, white blue light can provide a helpful pick-me-up in the morning, you might want to turn off your laptop a few hours before bed. So, on the other hand, what you need in your life is natural light, because natural light could make you feel happier. Catching a few rays of natural sunlight during the day can make a world of difference. One 2014 studies found that people who had windows in their office exercise more, get more sleep on average 46 minutes a night additional, yeah, and had a better sense of overall well-being than those whose offices had no windows. Researchers believe exposure to natural light helps our body to stick their natural circadian rhythm so that they know when they feel alert and energetic and when to feel sleepy. And also help to reduce the symptoms of depression. Yes, natural light can even help to reduce symptoms of depression. In one 2013 studies, researchers found that for people with both vitamin D deficiencies and depression, 7 weeks of increased sunlight exposure in the form of increased outdoor time helped alleviate depressive symptoms. Another 2015 studies corroborated these findings. Instead of spending more time outdoors, volunteers in 2015 studies participated in light therapy, a process that involves regular, prolonged exposure to lamps designated to mimic natural outdoor light. Researchers found that a combination of light therapy and antidepressants was significantly more effective in treating depression than antidepressants alone. Of course, light alone can't cure depression, but researchers believe natural light may be a useful tool in alleviating its symptoms. Light can also affect your appetite. This is also another steps to help depression. Okay? Studies have found that light affects how much we eat, how fast we eat, what kind of food we are in the mood for, and even our perception of flavor. In general, we eat slower and consume less food in restaurants with softer, dimmer lighting. However, we may also be more likely to order unhealthy food in darker restaurants. Researchers believe this is because softer lighting may make us less alert and more relaxed, which means we are less likely to think through our food selections and assess how caloric they are, but more likely to eat at a leisurely pace instead of scarfing on our food down. But light doesn't affect what we eat. It can be have even more it can even have an impact on how things taste. One 2009 study, for an instance, found that background lighting affects how much a group of volunteers liked a particular brand of wine, possibly because the way different kinds of light affected the wine's color. Alright, so that's all for our class today. Thank you so much and have a nice day. And always stay in the natural light. Thank you so much.